The next problem, the amount of water in a storage tank in gallons is modeled by a continuous function on the time interval from 0 to 7, where t is measured in hours. In this model, rates are given as follows. The rate at which water enters the tank is f of t, equal to 100 t squared sine square root of t gallons per hour for 0 to 7, and the rate at which water leaves the tank is g of t is equal to 250 for 0 to 3 and 2000 for 3 to 7 gallons per hour. We have the graph of f and g, which intersect at t equals 1.617 and t equals 5.076 are shown in the figure to the side there instead of above. At time t equals 0, the amount of water in the tank is 5,000 gallons. So the first question is, how many gallons of water enter the tank during the time interval from 0 to 7? Right, so our function for entering is f of t above. So I had that function entered here, and all we need to do is take the integral of that from 0 to 7. So I go back out to the main screen, math, option 9, fn int, vars, yvars, function, y1, comma, x as my variable of integration from 0 to 7, and it tells me that 8,263 now we want to round this to the nearest gallon, so 8264 gallons. Okay, so that one was pretty straightforward. Second, we want to find the intervals during which let's get the calculator out of the way. We want to find the intervals during which the amount of water in the tank is decreasing. Well, if you recall from these types of problems, water will be decreasing when the amount of water in the tank will decrease when the rate at which it's entering is less than the rate at which it's leaving. So the rate at which it's leaving is greater than the rate at which it's entering. And from our graphs here, I highlight in green the function that gives us the rate at which water is entering, and I'll highlight in red the rate at which water is leaving. So you can see at the very beginning, from time t equals 0 until the graphs intersect, the water will be leaving at a rate greater than the rate it's entering. So the first interval will be from 0 to, and we're given that point, 1.617. And from that point on, the rate at which it's entering is going to be much greater up until time t equals 3. At times t equals 3, it jumps up again, and the rate at which water is leaving is greater than the rate at which water is entering until we get to the intersection point. So that would look something like this. From 0 to 1.617 and from 3 to 5.076, over those two intervals, the rate at which water is leaving is greater than the rate at which water is entering, and therefore the water level will be decreasing, or the amount of water in the tank will be decreasing. Then we want to find for t times between 0 and 7 when the amount of water in the tank is at its greatest. So, and to the nearest gallon, compute the amount of water at this time. Well, we know that water has to be we know that to find the maximum amount of water, we would either look at endpoints or at critical points. So our endpoints are pretty straightforward there. They're at 0 and 7. Our critical values are going to be at the places where the derivative is equal to 0, or where the derivative changes sign, and our derivative overall is the entering minus the leaving. So we'll also have those two critical values at 1.617 and 5.076. But you should notice that both of those are minimums because the derivative is going to change from negative to positive at that point. Those are going to be relative minimums. Now the only other place we need to consider is at 3 because the derivative doesn't exist there. So mainly we have to calculate the derivative at 3 and at 7, and I'll do that in the next video, and one of those two answers is going to be our maximum.